So, you've probably played around with an AI that can whip up an email, a poem, or even some code, right? We call those large language models, and at their core, they think in words. But here's a wild thought. What if that exact same kind of AI, the one with a text based brain, could also create absolutely stunning, photorealistic art? Well, today we're digging into some research that asks that very question. All right, let's get right into it. For the longest time, the AI world has been pretty much split down the middle. You've got the models that handle language, and then you've got the models that create images. And they've worked in fundamentally different ways. It's like they had two separate brains. This has been a huge hurdle for anyone trying to build a single, unified AI. But why? Why the split in the first place? Well, it all comes down to two totally different philosophies. So on one hand, you have what are called diffusion models. Now, think of these as sculptors. They start with just a block of random static, pure noise, and then they meticulously chip away at it, bit by bit, until a crystal clear image emerges. This is the magic behind pretty much all the AI art you've seen. Then, on the other hand, you have autoregressive models. These are the writers. They build things one piece at a time, predicting the very next word in a sentence. It's the engine that runs things like GPT. See? Two completely different ways of thinking. So there you have it, these two competing methods, the sculptors and the writers. Let's really break down why one of them has just completely taken over the world of AI art, while the other was, for a long time, kind of seen as a long shot. Right now, the diffusion approach is king, no question about it. Models like Stable Diffusion and the tech behind Midjourney and DALL-E 3, they're all built on this sculpting from noise idea, and they are incredibly powerful. They've really set the gold standard for quality and performance. They are, for sure, the champions to beat. And then you've got our challenger, the autoregressive model. Its whole logic is actually pretty simple, but it's powerful. Based on everything so far, what comes next? Now, for text, that makes perfect sense. But for a picture, how on earth do you apply next word prediction to a photograph? That has been the billion-dollar question. So how do you actually do it? How do you take that next word logic from language and make it work in the visual world? Let's take a look. The trick is to make an image behave like a sentence. So first, you basically chop the image up into a grid of tiny little pieces, kind of like a mosaic. Each one of those little pieces becomes what's called a visual token. Then, the AI just does what it does best. It looks at the sequence of tokens it's already laid down and predicts which one should come next. And finally, once the whole sequence is generated, token by token, it just stitches them all back together to form the complete image. But here's the thing. For years, this token by token approach just couldn't keep up. The quality wasn't there compared to diffusion models. It was often slower. The images were lower fidelity. Honestly, it kind of seemed like a dead end. But then a new model called LlamaGen came along and decided to take this old idea and prove everybody wrong. So what was LlamaGen's big secret? I mean, how did it take this underdog method and turn it into a genuine contender? Well, it all boiled down to absolutely perfecting three fundamental building blocks. The researchers didn't invent some brand new, crazy technique. Instead, they just went back to basics. In their own words, they systematically went back and improved three key things: how images get turned into tokens in the first place, how big the models can get, and, of course, the quality of the data they learn from. Okay, their first huge win was the tokenizer. You can think of a tokenizer as a sort of visual dictionary, a codebook that the AI uses to describe different parts of an image. Now, older models were super inefficient. They'd only use a tiny fraction of their own dictionary. LlamaGen's is completely different. It uses a staggering 97% of its codebook. That means it has a much, much richer and more efficient visual language to work with. Second, they went big. And I mean really big. They built their image generator on the very same architecture as those powerful Llama language models and scaled it all the way up to over 3 billion parameters. And because they used a standard, proven language architecture, they could just borrow all the optimization tricks from the language model world and just focus on pure scale. And third, they were incredibly smart about their data. They used this two-stage process. First, they trained the model on a massive, diverse dataset of 50 million images just to learn the basics of what the world looks like. But then, they fine-tuned it on a smaller, carefully curated collection of 10 million beautiful, high-quality images. So this basically taught the model not just what things are, but how to make them look good. So they nailed the tokenizer, they scaled up the model, and they curated the data. But did it actually work? Let's look at what happened when LlamaGen went head-to-head with the diffusion champions. So the standard benchmark for image quality is something called the FID score. Now, you don't need to know all the math behind it, just this. A lower score is better. It means the AI-generated images are closer to real photos. And LlamaGen, it achieved an FID score of 2.18. To put that in perspective, that is an absolutely incredible result. And this really shows you just how good that score is. We can see LlamaGen, our autoregressive writer model, not just competing with, but actually beating top-tier diffusion models like LDM and the very highly regarded DIT. A score of 2.18 just edges out DIT's 2.27. The writer just officially outsculpted the sculptor. Okay, but there's always a catch, right? With these autoregressive models, the big hangup has always been speed. Generating an image one tiny piece at a time can be painfully slow. So did LlamaGen manage to solve this problem too? Well, yes, they did. And here's the genius part. Because LlamaGen is built on a standard language model architecture, they could just grab off-the-shelf optimization tools from that world like VLLM. And the results? A mind-blowing speed-up of over 400% compared to the baseline. They took the model's single biggest weakness and turned it into another huge strength. So LlamaGen managed to achieve incredible quality and incredible speed. But this breakthrough, it isn't just about making better AI art. It's pointing towards something way more fundamental for the future of AI. You know, for years, we've needed these specialized models for specialized tasks, a language brain over here, a vision brain over there. LlamaGen's success completely challenges that whole way of thinking. And the researchers themselves, they state their ultimate goal pretty clearly. They want a unified model, one single architecture, one training process that can just seamlessly work across all different kinds of data. So the crucial point is this. LlamaGen proved that the exact same next token prediction that writes your emails can also create your art, and it can do it at a world-class level. This really paves the way for what we call true multimodal AI, a single system that doesn't need two different brains to see the world and to create in it. This research strongly suggests that that future might be a lot closer than any of us think. I mean, just imagine what happens when the same AI that writes your code can also design your logo, compose the music for your video, and then animate the whole thing all from within the same single mind. That's the future LlamaGen is pointing towards.